So the hyperbola is going to be the last of the conic sections we're going to discuss. And the definition is very similar to the definition of an ellipse. Only where an ellipse talked about the sum of the distances being constant, a hyperbola talks about the difference of the distances being constant. So we have the same basic components. We've got the center, and we're going to do just like we did before, and leave that at the origin for now. Then we have a focal point. Let's put it out here just to give us an example to look at. And an ellipse, a hyperbola looks like this. Only correct for my dubious drawing skills, right? It should be nice and symmetric. Okay, so we've got the center here. We've got focal points here and here. And the line through the focal points, the line that kind of cuts the hyperbola in half, is called the transverse axis. And the line through the center perpendicular to that one, right, the one that kind of cuts it into two pieces this way, is called the conjugate axis. We're going to have kind of the same pieces. The distance from the center to the focal point is going to be, we'll call that C. The distance from, they're not usually called the vertices, but to these points here, right, these closest points, this distance is going to be A. And there's going to be a B, but the B is a little unusual, so we'll circle back to the B a little later in the lecture. So the equations should look very familiar. This really is practically identical to the equation of an ellipse. The only difference is you've got that minus sign in the middle, right? And like I had on my drawing, right, the focal points are at minus C plus C, and the vertices, we'll go and call them vertices, are at minus A and A. And you have this very similar relation here between A, B, and C to what we had with an ellipse. Now, you notice these are different, right? The X and Y positions changed. And that's how, with a hyperbola, we determine left, right versus up, down. Right? Here, the X is first, which means the transverse axis is in the X, if you will, direction. So this is going to be a side-to-side hyperbola. And when the Y squared is first, that gives us an up-down hyperbola. Okay, so now we're going to go through all the same things we did with an ellipse, right? We're going to find an equation. We're going to, we're given properties, we're going to find an equation. Given an equation, we're going to find the properties, and then we're going to do the exact same transformation business to relocate the center. So let's take a look at this thing, right? I want to find the equation of a hyperbola whose center is at the origin, that has a focus at negative 5, 0, so 1, 2, 3, 4, 5, 0, and has a vertex at 2, 0. Well, remember, these things are all symmetric. So if there's a vertex at 2, 0, there's another one at negative 2, 0. And if there's a focus at negative 5, 0, then there's another one at 5, 0. And you notice, just like with an ellipse, the focal points are always inside the figure. Okay, so what do we know? First, I know that this is a left-right hyperbola, right? So I'm going to start with x squared over a squared minus y squared over b squared equals 1. And a, that's this distance from a vertex to the center, so A is 2. And C is this distance, the distance out to a focal point, and that's 5. All right, so let me put the a in here. This becomes x squared over 2 squared. That's 4. I'm going to go to my equation here. B squared equals c squared minus a squared. So let's see. C squared is 25. A squared is 4. So b squared is 21 minus y squared over 21. And that's it. That's my hyperbola. Right? We're done. All right, so let me give you one, right? Try pausing the presentation, work this one out, see what you come up with. So we're starting with the same configuration. The center is at the origin. Now the vertex is at 0, 2. That distance is 2, and that's good because that's always going to be A. And there's a focus at 0, -3. Excellent. C is -3. Now, if the focal point, there must be another one here at 0, up 3. So my hyperbola looks like this, right? It's going to be an up, down 1. So I'm going to do y squared over a squared minus x squared over b squared equals 1. And let's see, so a is 2, that's y squared over 2 squared is 4, minus x squared over, so let's see, b squared is c squared minus a squared, that's 3 squared minus 2 squared, which is, let's see, 9 minus 4 is 5. And there is my equation. Really all there is to it so far. Okay, so how about if we want to move the center? Well, I'm going to do just the exact same thing. Right, the exact same thing. If I want the center to be at h comma k, then my equation will be x minus h squared over a squared. Whoops, no, not plus, right, that's an ellipse, minus y minus k squared over b squared equals 1. Or the y's and k's could be reversed, right, depending on the left, right versus up, down orientation. So, how do we do this? Well, we've got our relocated one now, and we're going to do this just like we did with ellipses and hyperbolas. First, we're going to ignore the center relocation. I'm going to do this whole process assuming that the center is at the origin, then I'm just going to translate it. So let's see. The center is at 1, 2, 3, -2. Okay, and then there's a vertex at 3, 5. So I'm going to go over 3, up 1, 2, 3. Let's see, over 3, up 1, 2, 3, 4, 5. There's my vertex, and the focus is even higher. It's at 3, 8. So my parabola is like this. All right, that's just the upper half, of course. So A, whoops, I got to go all the way down, don't I? Not just down to the axis. Here, A is 7, and C is 10, which means, let's see, B squared equals C squared minus A squared. That's 10 squared is 100. 7 squared is 49. B squared is 51. And that gives me my equation, right? This is an up-down. So it's going to be y squared over a squared, that's 49, minus x squared over b squared, that's 51, equals 1. And now I just have to move the center, right? If I want to move the center to 3, -2, so this will be sure you get these in the right order now. The -2 is the y, is the vertical shift. So this will be y plus 2 squared over 49 minus x minus 3 squared over 51 equals 1. And that's it. I'm done. Right? There's my hyperbola. Okay, so what if we want to go the other way? What if I give you an equation and I say, okay, find all of those parts? Well, we're going to do exactly the same thing that we did with ellipses. It's going to be an exercise in completing the square. Right, so first, let's see, I'm going to do x squared plus 4x, and I'm going to leave a little space here, right, because I got to add something to make that a perfect square, minus, and now I'm going to factor a minus 4 out of the y. So this will be minus 4y squared minus 2y, and again, leave a space here, equals minus 4, right? I'm going to go ahead and move that minus 4, or that 4 over to the other side. All right, so what do I have to add? Remember how we do this, right? For the x, it's going to be 4 divided by 2 squared, which is 4. So I'll add 4 to both sides. And for the y's, it's going to be minus 2 divided by 2 squared, which is 1. So I'll add 1 here. Remember, because of this minus 4 out in front, I actually added minus 4. Okay, so I'm going to subtract 4 from this side. And now I'm going to do my factoring. This is x plus 2 squared minus 4 times y minus 1 squared equals negative 4. And I need that to be 1, right? Because that's how my equation, my general equation of a hyperbola works. So I'm going to divide everything by minus 4. And so let's see. You notice that the signs switch. The y's are now going to be positive. So this is going to be y minus 1 squared over 1. And I'm going to leave it over something, right? Because I want to see what that a is going to be. Minus x plus 2 squared over 4 equals 1. Okay, excellent. So now I know where my center is, right? My center is, and again, be sure you get these in the right order, right? The y comes first, which can be a little confusing. It's going to be negative 2 comma 1. So let me put that on my graph here. I'm going to go negative 2, 1. There's my center. And I know this is an up-down hyperbola, right? Because it's the y that's in front. So let's see, what else do I know now? A squared equals 1, which means a is 1. And b squared equals 4, which means b is 2. And that's good. That'll give me the vertices, right? I'm going to start here, and I'm going to go up 1 and down 1, and that gives me the 2 vertices. So it's going to be over negative 2 up 0 and over negative 2 up 2. And then I need c. Well, c squared equals a squared plus b squared, which is 1 plus 4, which means c is the square root of 5. And that's good, right? Square root of 5 is 2 point something, which is which is greater than my a value, which is good because that's putting the focal points up here and here, which is inside the hyperbola, right? The hyperbola is going to look like this, right? So that is what we expected to happen. So where are my focal points like these? I just kind of shortchange them a little bit, I guess. It's going to be negative 2 comma 1 plus or minus the square root of 5. I would just leave it at that, right? We're not actually graphing these, so I don't need to try converting these to a decimal. Okay. Now, where does this b come in? Okay, these hyperbolas, they have asymptotes, right? There's a limit to how fast they're increasing, right? And the way this works, right? And I'm just going to do this one here. It'll be the same thing for the other one, right? We have this distance here, the distance from the center out to the vertex is a. And there you've got your hyperbola. Well, if you draw a box, right? If you go up B and kind of draw a box here, and let me do it on the other side, right? And here. And then you go down B also. And let me get the other half of my hyperbola in here. The asymptotes are found by connecting the corners of the box, right? So this is actually easier than it looks, right? They're going through the origin, so the y-intercept is 0, and the slope. Look at this one here. It goes up B over A to get from this point to this point. So the slope is B over A. And for the one on the other side, right, I go up B and then I go A to the left. So that's minus A. So the slope of this asymptote is minus B over A. It's the same way around, right? If I want to do the other one here, right? If I want to do the up-down one, now this distance is A. And I'm going to draw my box, right? I'm going to go up A and I'm going to go over B. And I'm going to draw a box here. And now you can see what the slope of this one is, right? The slope, to get the slope of this tangent line, I go up A and over B. And if I go in this direction, right, this tangent line is going to be up A. Sorry, that's my same one. It's over on this guy. The slope of this tangent line is going to be A to the left. So that's negative, excuse me, it's up A again. And to get to that point, I go to the left. So it's going to be negative B. The slopes are the same, right? The A's and B's are just flipped depending on the orientation. Okay, so let's look at an example. And again, I'm starting off with this. We're back to simple, right? I've got the vertex, or excuse me, the center of the origin. So let's divide both sides by 100, and I get x squared over 4 minus y squared over 25 equals 1. And all I was asked to do here was find the hyperbolas. Was to find the asymptotes. Well, this is a right-left hyperbola, and A squared is 4, which means A is 2. So to find my box, right, I'm going to go over 2 and over negative 2, and then B squared is 25, which means B is 5. So it'll be up 1, 2, 3, 4, 5, right? That's 5, 0, and I'll go down 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. There you go, negative 5, 0. So here is my box. Whoops, only go over 2. I went a little too far on some of those. There you go, should have stopped right there. And then down here. Okay, so my first asymptote is running like this. And let's see, what is its slope? Well, the coordinates of this point here, the corner of the box, are 2, 5. So my slope is 5/2, which means my first asymptote, let's call it y1, is 5/2 x plus 0, or just 5/2 x. And for the other one, I mean, you can figure it out if you like, or it's easy to remember, you just change the sign of the slope. But we can see it happen. This point here is negative 2 comma 5, which means the slope now is 5 over negative 2, which makes y, let's call it y2, my second asymptote, negative 5 halves x. Right? And there they are. Okay, so how about this guy? Okay, so this guy is translated, right? But look, I'm going to do almost the same stuff we've been doing. I'm going to do this like the center was at the origin, find my asymptotes, and then translate them, right? And then I'm going to replace the x in my asymptote with x minus 5 and the y with y plus 2, and then it's just a little cleanup. All right, so let's see. What do we have here? First, a is 3, and b is 8, and I have an x squared minus a y squared. So this is a left-right hyperbola, so I'm going to go over 3 up 8, that's up here. Then I'm going to go over 3 to the left, up 8. Then I'm going to do the same thing and go down. Over 3, down 8. Over negative 3, down 8. And that gives me my box. A rather large box for this one. Okay, so my asymptotes are based on the box, right? It goes up through here. And let's see, this point is 3 comma 8, which means my slope is 8 thirds. And the slope of my other one, we've got the pattern now, right? It's negative 8 thirds, which means my y asymptotes are y equals 8 thirds x and y equals minus 8 thirds x. Or they would be if the center was at the origin. But it's not. It's been translated 5 units to the right and 2 units down. I'm just going to do those exact same translations to my asymptotes. I'm going to make this one y plus 2 equals 8 thirds x minus 5. And this one will be y plus 2 equals 8 thirds x minus 5. And now, yeah, I'm going to go ahead and clean these up. I mean, there's fractions, but we can, whoops, I lost a minus sign. Sorry about that. There we go, minus 8 thirds. Yeah, there's fractions, but we're not afraid of fractions. So let's see. This one is y plus 2 equals 8 thirds x minus 40 thirds. And then I will subtract 2, which is 6 thirds, right? I'm doing a common denominator. And I get y equals 8 thirds x minus 46 thirds. And I'll do the same thing over here. This is minus 8 thirds x plus 40 thirds. And then I will again subtract 6 thirds from both sides, and I get y equals minus 8 thirds x plus 40 minus 6. That's 34 thirds. And there are my 2 asymptotes.